Prof.
Good morning, everyone. You may have be seated. So, let's proceed to our lesson for today. Has anyone tried to advance reading? Anyone?
We have lesson to advance read. Look,
What do you mean, la? I gave this topic last week. So you must have done that.
who told that? Guys, quiet, Mama.
Don't you try to get me angry or... Prof! What? Prof, we did our group study last week po, but we did not understand anything of it. Maybe a little, but can you explain it to us? You're trying to trick me, huh? So, okay, I guess. I'm glad to teach you the lesson for today. This is all about energy storage. So listen carefully to what will I discuss because we will need this. Or you will need this because we were having a quiz. Quiz? Yes, Miss Madonna. You heard it right. I said quiz. So let's start with the discussion. So you all know that our topic is about energy storage because I already said it and I already gave it.
Yes, Prof.
Yes, but you didn't even read it. Anyways, let's start with the definition of energy storage. Oh wait, I forgot the TV screen. Can you see it? Can you see it clearly?
Yes.
Oh. So, the energy storage is a fundamental concept in chemistry. It's all about how chemicals can store and release energy through various reactions. So, from the word itself, it means it process on how it stores an energy for a lateral use. It is a it balances the supply and demand of energy. Sounds interesting, just like you po, Prof. Interesting. Sounds like you're flattering me. That's not gonna work, girl. I've already done that with my previous professors. You still have quizzes. So, let's start with basics. Here again, this is an exothermic. An exothermic is a chemical reaction that releases energy into its surroundings. And I'll give you an example with that. Imagine a chemical reaction as a way of rearranging atoms. In some reactions, the reactants contain more energy than the products. We call this exothermic reaction because they release energy, often in the form of the heat. So energy is stored in the reactants and released in the product. Exactly! Think of it like potential energy stored in the reactants, which is released during the reactions. So here's another example of an exothermic. Normally in combustion, there is a paper and oxygen, water and carbon dioxide, then heat and light. So, the combustion of a piece of paper serves as a vivid illustration of energy transformation. It demonstrates the potential energy stored in chemical bonds can be converted into kinetic energy, appearing as heat and light. This simple yet profound example reinforces the universal law of energy conservation, which is enriching our understanding of the world around. Oh, I get it. But what about this reaction, something called endothermic reactions? Good question, Miss Martha. So, an endothermic is quite an opposite to an exothermic because the reactant of an endothermic have lower energy compared to the products. And they absorb energy from the surroundings, while exothermic is releasing energy from the surroundings. So you get it? An example is photosynthesis in plants, where they take in energy from sunlight to convert carbon dioxide and water into glucose and oxygen. Huh? But how does this relate to everyday life? So let's talk about something we use daily, like some batteries. I have slides for that. Here. As you can see, batteries are essential devices that store and release chemical energy. They consist an anode, cathode, and an electrolyte. When you use a battery, a chemical reaction takes place between these components, releasing energy that powers your devices. Batteries. I never thought that in that way.
Look.
What? Prof, can you show us how it works?
Sure, Miss Anne.
So let's take a look inside of the battery that had been dissected. This is not the actual picture of a battery, but another alternate for one. So let's take a look of this. Excuse me. Here's the anode, the cathode, and electrolyte. And when you connect the battery to a device, electrons flow from the anode to cathode, and the flow of electrons is what powers your devices. Wow, it's like magic. What kind of reaction that's happening inside? Well, in a typical alkaline battery, the anode contains zinc, and the cathode contains manganese dioxide. They undergo redox reactions, then transferring electrons and producing chemical products like zinc oxide and manganese dioxide hydrate. And it releases energy in the process. I never realized how much goes into something as simple as battery. But what about energy storage in nature? Nature is full of examples. Photosynthesis, as I mentioned earlier, is a process where plants use solar energy to store chemical energy in the form of glucose, which they can later use for growth and also in metabolism. So, Prof, these natural processes are all about energy storage for the long term? Yes, exactly. It's all about storing energy for later use. Just like how we store energy in batteries. Nature has its own unique ways of storing and utilizing energy efficiently. Prof, since our lessons about energy storage, can I ask a question about it? You are already asking, Iha.
Prof.
Just kidding, what is it? Well, I saw some latest invention on social media, and there's something called Next Generation Energy Storage System, or NGENS. Yeah. So what's the question there? Why are they so crucial for our future energy needs? Well, I'll explain first what is NGENS. So, NGENS is Next Generation Energy Storage Solution. So everyone could know about it. From the word itself, it is an advanced technology and methods for storing energy, typically in the form of electricity, with improved efficiency, capacity, and sustainability compared to the traditional energy storage. So you ask, why are they so crucial for our future, right? First, They are instrumental in mitigating climate change by making renewable energy sources more reliable and accessible. Second, they enhance energy security by reducing our reliance on finite and unreliable fossil fuels. Okay, then third, they facilitate the integration of renewables into our energy grids, paving the way for a cleaner and more sustainable energy. Then lastly, they stimulate economic growth and innovation. It is an imperative that we continue to invest in and develop these technologies to ensure a brighter and more sustainable future for generations to come. Then how is it different to the energy story before? Well, the next generation energy storage solution or system differ from their predecessors in several key ways. They are typically more efficient, capable of storing and releasing energy with reduced losses. They often utilize advanced materials and technologies such as solid-state batteries or supercapacitors, which offer high energy density and I think it is faster charging and discharging. Additionally, these systems tend to be more environmentally friendly with a focus on sustainability and reduce reliance on fossil fuels. I always forgot the word fossil, sorry. Fossil fuels, then contributing to a cleaner and more sustainable energy landscape. Prof, what do you think are the disadvantages and advantages of this? Well, as a research, the next generation energy storage system present a bright avenue towards a more efficient and eco-friendly energy. They bring several key benefits like heightened efficiency, cutting-edge technologies, speed energy transfer, and environmental advantages. These perks have the power to transform how we store and use energy, but like most innovation, they do come with their share of hurdles, such as higher initial costs, added complexity, and scalability concerns, and the inherent uncertainties. Which is linked to new technologies. So while they offer immense potential, addressing these challenges is vital to make the most of these advanced energy storage solutions. This is truly fascinating, Professor. I'm glad you find it fascinating. Chemistry is all around us, and understanding energy storage is just one way to appreciate its importance. Thank you, Professor. I'm sure everyone wants to learn more about this topic and its practical applications.
Huh? Only you.
What, Alexa?
Nothing.
We are really thankful. You are all very welcome, and I'm here to help you explore the exciting world of chemistry. Do you have any questions? Violence reactions?
No.
Okay then, we're done. Please pass your assignments. We have assignments?